all, in this video we're going to talk about the manometer. Okay, the manometer is a device used to measure pressure. Okay, so we're in the topic of pressure. And to understand the manometer, look at this diagram. So this is a U tube, okay, a U-shaped tube. And if it's not connected to anything, this is how the water levels are going to sit. Okay, you can see that both are at 0 or at the same level. So there's a liquid here to indicate that. When pressure is applied at one of the legs, okay, you will get a shift in the levels. So when a pressure is applied here, of course, the level here will go down. And where does the water go? But to the other side. So this difference in the height of the two levels of fluid is the pressure. Okay, this can be converted to measure pressure. So let's see how that goes. The pressure at point 2 is the same as pressure at point 1. This is in this case because it's open to atmosphere. Okay, both have atmospheric pressure. So P2 equals to P1, and the pressure change across a fluid column of height h is P equals to rho GH. So the change measured here equals to rho GH, and that is going to give you the increase in pressure. So pressure increase downward in a given fluid and decrease upward. What this means is as you go further down, there's a pressure rise. Alright, and if you go further up, there will be a pressure decrease. Okay, let us look at this very simple example. You have gas inside a tank and the pressure is measured using a manometer. Okay, one leg of manometer is attached to the tank and the other leg is open to the atmosphere. Okay, this is open to the atmosphere. So the pressure inside the tank is equal at all points until the connection with the manometer. Okay, until it is in contact with the manometer fluid. So the pressure in here and the pressure out here is the same. So this is the pressure that we want to find, pressure at point 1. Okay, but we should also see that pressure at point 1 is equal to pressure at point 2. The reason for this is pressure is the same at the same height. So remember, it's the same fluid. All right, this is the same fluid throughout. Therefore, the pressure is the same. Point 1, so you don't have to worry about this. You can just find the pressure at point 2. So that simplifies everything. So pressure at point 2 is then the atmospheric pressure plus the difference, rho GH. So just by knowing what the height is, you can determine the pressure inside a system. Okay, so we go through one example. So this is a similar diagram as the example just now. A manometer is used to measure the pressure in a tank. The fluid has a specific gravity of 0.85. The manometer column height is 55 cm. That's right here, 55 cm, as shown in the figure. If the local atmospheric pressure is 96 kPa, determine the absolute pressure within the tank. So you are given PATM is 96. So if you recall that I've explained to you, PATM is not a fixed value. So it is commonly taken as 101.325 kPa at standard conditions. Okay, but at higher elevation, you have lower pressure, right? So this might simply be at a higher elevation. So that's why it's less than 101.325. So this is atmospheric pressure. All right, all this is atmosphere until the surface of this leg. And another thing is specific gravity is 0.85. So if you recall, SG, specific gravity, is simply the ratio of the density of this fluid over density of water. Okay, SG will give you the density. And what else? Nothing else. So we can solve for pressure inside the tank. So pressure inside the tank, as I explained in the previous slide, we want to find it at this point on the left leg. However, because it's the same fluid throughout, you can just jump over to the other side and you can get this level. Okay, so first Sg is the ratio. So the density of the fluid is 850 kilograms per meter squared. And then you can just solve for P inside the tank. So that's atmospheric pressure going downwards plus rho GH. Okay, so don't forget that rho GH is in Pascal and PATM is in kilopascal. So you have to divide this whole thing by 1000. This should be the answer. Okay, the question, what is the gauge pressure inside the tank? So I hope you know by now that gauge pressure is simply rho GH, or it's just the pressure minus PATM, which is rho